Continental drift and seafloor spreading. 500 years ago, when discoverers set out to study the continents and began making maps, many people started looking at maps and wondering why the coasts of several continents matched so neatly together. For example, the coasts of Africa and South America look as if they could fit together like a jigsaw puzzle piece. Back in the 1700s, geologists thought that the continents had always remained in the same place, and that is until the early 1900s when one scientist by the name of Alfred Wegener became curious about the relationship of the continents. Wegener hypothesized that the continents were once joined together in a single landmass and then have since drifted apart. His idea that the continents slowly moved over the surface became known as continental drift. According to Wegener, the continents drifted together to form the supercontinent Pangaea. Pangaea means all lands, and according to Wegener, Pangaea existed about 300 million years ago. This was the time when reptiles and winged insects first appeared. Over tens of millions of years, Pangaea began to break apart, and the pieces of Pangaea slowly moved toward their present-day locations, which are the continents today. However, these continents are still moving. Wegener gathered evidence from different scientific fields to support his ideas about continental drift. He studied land features, fossils, and evidence of climate change. For example, when Wegener pieced together maps of Africa and South America, he noticed that the mountain ranges on both continents line up. He also noticed that the European coal fields matched up with the coal fields in North America. Wegener also used fossils to support his argument. One example is the water reptile Mesosaurus. The fossil of the Mesosaurus has been found in places which are now separated by oceans. This reptile is not capable of swimming great distances across salt water, so Wegener inferred that this reptile must have lived on a single landmass that has since split apart. Wegener also used evidence of climate change to support his hypothesis when he showed that fossils of tropical plants are now found on an island in the Arctic Ocean. When these plants lived about 300 million years ago, the island must have been in a warm and mild climate. Unfortunately, Wegener could never provide a satisfactory explanation for the force that pushes or pulls the continents, and because of this, he could not identify the cause of continental drift, and therefore, many geologists rejected his idea. Wegener continued to collect evidence on continental drift to prove his theory, but unfortunately died in 1930 on an expedition to explore Greenland's continental glacier. In 1960, an American geologist by the name of Harry Hess found the evidence Wegener was looking for. He was a scientist who studied mid-ocean ridges along the seafloor. Mid-ocean ridges curve like the seam of a baseball along the seafloor and extend into all of Earth's oceans. The mapping of mid-ocean ridges made scientists start thinking, what are they and how do they form? Well, Hess came along and proposed a radical idea and suggested that a process that he called seafloor spreading was causing this. Seafloor spreading continually adds new material to the ocean floor. In seafloor spreading, the seafloor spreads apart along both sides of a mid-ocean ridge as new crust is added. As a result, the ocean floors move like conveyor belts, carrying the continents along with them. Several types of evidence supported his theory of seafloor spreading, including eruptions of molten material, magnetic stripes in the rock of the ocean floor, and the ages of the rocks themselves. This evidence led scientists to look again at Wegener's hypothesis of continental drift. In 1960, scientists dove to the ocean floor in a little small submarine and found strange rocks shaped like toothpaste squeezed from a tube. Such rocks form only when molten material hardens quickly after erupting underwater. These rocks showed that molten material erupted again and again along this mid-ocean ridge. When looking at patterns in the rocks of the ocean floor, they also found more support for seafloor spreading. We discussed earlier that the Earth behaves like a giant magnet with the North and South Pole. Well, Earth's magnetic poles have reversed themselves many times during Earth's history, with the last reversal happening around 780,000 years ago. Scientists discovered that the rock that makes up the ocean floor lies in a pattern of magnetized stripes that holds records of reversals of Earth's magnetic field. And the final proof of seafloor spreading came from rock samples obtained by drilling into the ocean floor. Scientists determined that rock samples farther away from the ridge were older than rock samples taken closer to the ridge. This showed that seafloor spreading really has taken place. You may be asking, if the seafloor keeps spreading at the mid-ocean ridges, then wouldn't the ocean floor keep getting wider and wider? Well, actually no. Parts of the ocean floor actually plunge back in to the deep underwater canyons called deep ocean trenches. And at these trenches, in a process that takes tens of millions of years, part of the ocean floor sinks back down into the mantle. This process by which the ocean floor sinks beneath a deep ocean trench and back into the mantle is called subduction. Seafloor spreading and subduction actually work together, and they move the ocean floor as if it were on a giant conveyor belt. Okay, it is time to show what you know.